Programming in C++, the name of unit, functions in C++, and working with object. Topics are concepts of C++, class, object. In C++, there are a few new concepts regarding the functions like inline functions, default argument, constant arguments of function, function overloading that we are going to cover in this video. The concepts about class and object. These are the main concept of object-oriented programming. How to access a class member and how to allocate the memory for the object, that are also the main part of this current video. Objectives of this video are the main function, function prototyping, call by reference and return by reference, inline function, default arguments, constant arguments, function overloading, class and object, accessing class members, and memory allocation for the objects. The main function. Basically, the main function is a starting point for the execution of any program. In C++, the main function returns the value of integer type. So, by default, it returns the value of the integer type. So, the prototyping of the main functions are like int main. In main, there are two arguments, int argc and character rv. What is a function prototyping? Basically, the word prototype describes the function interface to the compiler by giving details such as the number and the type of arguments and the type of return value. That means it is basically known as a declaration of the function in C. The syntax is like this. This is a return type first. So whatever value that function is going to return, that data type, the name of function, and in bracket argument. For example, if the name of function is sum, there are two arguments x and y, and it will return the addition value of this x and y. Then integer is a return type of this particular function. So write int sum, int x, int y. This is known as a function prototyping in C++ for the function sum. Call by reference and return by reference. C++ provides the very easy and effective solution with the use of reference variable. First of all, if we are going to use the reference variable, then ampersand symbol is used. For any reference variable, the function prototype is like this, that void exchange. For example, the name of function is exchange, which is used to interchange the two values. Here there are the two arguments x and y. Okay. So there are two arguments with reference int ampersand, int ampersand. Okay. But when this function is called, at that time, it is called like this way, exchange xy. So this x and y, these are the arguments. Here this x is passed to this int ampersand. See here, it passes the argument like this, that int ampersand, if any variable is defined, for example a, then int ampersand a is equal to x. So whatever value is passed in x, it is the value of this ampersand a, and whatever value is passed through y, it is the value to ampersand b. For example, exchange integer x, integer y. Here this is a function prototyping. Okay. After that, void main int xy. Enter the two numbers. Here we are going to scan the two values of x and y. Now call this function exchange xy. Okay, so from this line, compiler jumps to here. Whatever value we have passed in x, for example, as a x we have entered value 5, and as a y we have entered value 10. Then here the value 5 is here and the value 10 is passed over here. Use a third variable. The value 5 is assigned to a. So using the temporary variable, exchange the value of a and b. But here the values are changed at the reference level. So in the address of this particular variables, the values are changed. Okay, so there is no need to return the changed value. So when here after completion of this exchange function, when the compiler comes here and going to print after exchange the value of x and y, then the value of x will be printed as a 10 and y it will be a 5. That means whatever values are changed, that values are changed at the address level, not at the in the temporary level in the variable. Okay, so the value of x and y are changed at address level. It is changed at the particular address. Now the next concept is inline function. Inline function basically functions provide the flexibility to use the same code many places in a program. Now why we have to make any function as an inline function? Function reduce the size of the program as well as it reduce the memory requirement at the run time. Okay. The advantage becomes overhead if the function needs time to call and return. That means when the function is passing the argument and transferring the control from one place to another place, and when the value is written, that means when the control backs to the main program, if that time is overhead, then the use of function that is not proper. Okay. So C++ goes one step ahead and provide one solution by inline functions which are capable of acting as both macros as well as functions. So when there is no need to transfer the control with the argument and with the returning value when the function is made as an inline function. So the syntax for the inline function is inline, return type, function name, arguments, and inside this opening and closing bracket, the body of function. But remember that the inline function, it contains only the one or two lines inside the body of the function. Okay. And there is it's like a simple function, but below the return type there is a keyword inline. Example, to find out the area of circle, here there is a one function plot area. Plot r, radius is passed as argument. The body of the function is written pi r square. Here this function contains only a single line of body, so we can define this function as an inline by putting the keyword inline before this function. Okay. Now when this function is called, from the void main execution is going to start. Enter radius, take the value of radius. Here area is equal to, from this point this function is going to call. Okay. So in place of passing the argument and control from this place to this place, at the compilation time, this function, the body of this function is set over here. Okay. So there is no need to call this function. There is no need at the runtime that pass the control from this point to this point and return the control from this point to this point, because because the code is already here. It is placed over here. Why? Because this function is an inline function. Okay. So directly it find out the radius at this point only and display the radius. Default argument. Now in C language, if we define the function with 3 arguments and we call that function with 1 or 2 argument in C, then it is the compiler error. So C doesn't allow that to call the function with less number of arguments. But C++ allows the calling of function with less number of arguments than listed in the header file. And C++ make it possible by allowing the default argument. That means the argument having the default values. In the few arguments, if we put the default value in that argument, after that, if we are not going to call with that particular default argument, then also C++ allow us to call that function. Now see the example. SetPoint is a one function. In that there are 2 arguments, x and y. But here we put the value of y is equal to 0. So if we assign any value to the variable, then this argument, it will be a default argument. That means without y, we are able to call this function setPoint. Okay. Now see here. Basically this setPoint, it put the coordinate in proper manner. Okay. So from the void main, there are 2 variables p and q. So in the variable p, we have take the value of x coordinate, setPoint p. So here setPoint is called only with a single argument, but this is allowed in C++. This same thing is not allowed in C language. So from here, it moves to this setPoint. Here the first value is assigned to x. So if we enter the value of x coordinate as a 5, then 5 is assigned to x. And it display in opening bracket 5, the first argument 5 and y as a 0. So it displays the 5 and 0. Now here enter the x and y coordinate, x and y. Here for example we enter the 5 and 10. Here setPoint once again it is called with 2 arguments. So from here it jumps here and 5 and 10. So here it will display like 5 and 10. Okay. So when we are going to call this setPoint with a single argument, then it will take the value of y as a 0. And that's why y is known as a default argument. Constant argument. So in previously C language also we can use a const keyword to make the argument to the function constant, so that inside that function you are not able to change the value of that constant argument. The syntax is like this: const data type variable name. Here there is a one function fun. In that there is a one argument integer x. We have made this argument x as a constant argument. Now inside the function integer x is equal to y. Then this is a valid task. The value of y is copied to x. Okay. X is equal to x plus 1. That means we are going to change the value of x. With this code we are going to change the value of x. But this is the invalid statement. Why it is invalid? Because here the x is a constant argument. So if the x is a constant argument, then we are not able to change the value of x. We can copy the value of x to y. That is a valid argument. And return y. So out of this 4 statement, only this statement is not valid because here we are going to change the value of x. That is not allowed here. Function overloading. C++ allows a multiple function with the same name, and that is known as a function overloading. But here, what must be the difference between the two functions with the same name? They must have the return type of that function may be different, or the number of arguments that may be a different. Okay. So compiler differentiate the two functions with the number and type of the arguments. For example, there are two functions area, but here there is a single argument r, and here there are two arguments. See here, plot area, plot r. So here return pi r square. So this function is used to find out the area of circle, and this function is used to find out the area of rectangle. Now from the void main, first we take the single value of radius to find out the area of circle. See out area of circle. When this function is called area circle, area radius, at that time here there is only a single argument. So the first one is going to call. Okay. So compiler pass here and return pi r square. So whatever value is there, it will display over here. Now here length and breadth, two arguments is given here, length and breadth. Okay. See out area of rectangle, area, length and breadth. Here this area function is called with two arguments. Okay. So this area is called here, is passed here, and this function it will return the L into B. So whatever the answer is there, it is written here and it is displayed over here. So the name of function is same, but the number of arguments are different. This is called the function overloading. Class. Class is a collection of objects. Basically, class have two types of data. The first is the data, it is known as a variable, and second is the functions inside that. So a class specification has generally two parts, the class declaration and the function definition. Okay. Class declaration describes the type and the scope of its member, and the functions definition describe how the class functions are implemented. The syntax for the class name. These are the specifier private variable declaration and function declaration. This is a specifier public, then public variable declaration and function declaration. And by default, if there is no specifier, then it will be a private specifier. For example, there is a class student. Inside that, there are two data, number and name. Okay, number, name. These are by default, these both are a private data members of the class, and in the public area, there are two functions, get data and put data. Objects. Objects is a basic runtime entities in object-oriented system. So object is a one type of class variable, you can say. The syntax to declare the object is class name space object name. The class name, in the previous example, the name of class is student, and here we have created three objects for the class student, S1, S2, S3. How to access the class member? First of all, what is a class member? So inside the class, whatever data and functions are there, these are called the class members. So in C++, we can access the class member from outside the class. We have to use the object of that particular class to access the class member. The syntax is the name of object dot variable name if it is a data, and if it is a function, then object name dot function name with argument. For example, class student. Integer inside that there are two data or two variable number and name, and two functions get data and put data. Void main, it contains inside void main student s1, that means s1 is a one object. So this number and name we cannot able to access from outside the void main. Why? Because it is a private data member of the class. So we can use this number and name inside this class only. But this get data and put data are the public member functions. So we can use this both the function outside the class. From here, s1 dot get data. S1 is object name dot function name. Once again, s1 dot put data. Object name dot function name. So using this method we can access the function. Now how the memory is allocated for the object. Here there is one example. Class book. It contains the two private members, title and price, and two public members, functions, get data and put data. Okay. Void main. This is a class name book. With the use of this class name book, here we are going to create the three objects, book 1, book 2, book 3. We can access this public member of the class through this object. So book 1 dot get data, book 2 dot get data, book 3 dot get data. Generally this get data function, it is used to access this data of that particular book. And this put data function, it is used to print the title and price of this particular book. Okay. So after getting the data, we print the data like book 1 dot put data, book 2 dot put data, book 3 dot put data. For example, in the book 1, we have entered the title CP and price 90. For book 2, we have entered title ACP and price 100. For book 3, we have give the title C++ and price 110. So how the memory is allocated for the object? See here. This is a book 1. For book 1, title and price for both different memory is created. So in the book 1 dot title, CP is 2 and book 1 dot price 90 is 2. Now for book 2, when book 2 access the function get data, then in the book 2, we have, for book 2 the title and price for both different memory is allocated. For book 2, we have entered the title ACP and price 100. So using this get data function, book 2 assign the title ACP and price 100. Same way for book 3, it also access the data using the get data function. In here, separate memory is there for the title and price of book 3. So the title of book 3 C++ and the price is 110. So here book 3 dot title, that is a C++, and book 3 dot price, that is a 110. So for data of each object, memory is allocated, and these functions are commonly used for this all the objects. Okay. So if I have created one more object, book 4, then title, to store the title and price of book 4, the memory is allocated. So there is no overlapping of memory to store the data of this particular object. So memory allocated for the object of the class book. Thank you.